Okay, here's a quick video on B2, graphing transformations of trigonometric functions. So we're just going to take a look at what sine, cos, and tan look like on a graph. So we're just going to pick some key points of sine, cos, and tan. So I'm going to pick values for my angles of 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then I know if I punch those into my calculator, use my unit circle, however you need to figure these out, I know the values of these are going to be 0, 1, 0, -1, and 0. And then I do the same thing for cos. So cos of 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then I know starting at 1, 0, -1, 0, 1. And then for tan, a quick way to get tan, I know tan is equal to sine x over cos x. So for all of these values, if I wasn't really sure what tan was doing, I could just do like 0 divided by 1. Okay, I know tan is 0. Must be undefined here. So at pi, tan would be 0 again. 3 pi over 2 would be undefined again. And at 2 pi would be 0 again. Okay. So let's take a look at those graphs. Okay, so my sine curve, it's going to go through. So I'll just put pi over 2, pi, 3 pi over 2, and 2 pi. Negative pi over 2, negative pi. Let's put a couple values on here. Pi over 2, pi, 3 pi over 2, 2 pi. And the same thing for my tan graph, just to get a scale on here. Okay, sorry. Alright, so I know my sine curve, 1 and -1. So I know my sine curve's going like that forever. Then I know my cosine graph, oops, that was supposed to be -1, is starting at 1, going through 0, like that. And then tan is undefined at pi over 2, oops, pi over 2, 3 pi over 2, negative pi over 2. And then at all of these values, it's 0. And it's doing that kind of curve every time. Okay, so you should know what the original graphs look like, and you can easily get all these points by using your calculator if you don't have them memorized. But those are like these tables here. Sorry, I'm just trying to scroll up. So these tables here are what I like to call the key points of the graph, or critical points or something. So we're going to learn how to transform these graphs. Okay, so first let's just talk about their key features. So all of these graphs have the same key features. They all have an amplitude equal to 1. So the amplitude is how tall it is from the middle of the graph to the maximum. Or if you take the maximum and the minimum of the graph, it's half that distance. So between the max and a min, it's a total distance of 2 units. It's going from -1 to 1. So that's 2. And the amplitude is half that for all of these. Actually, not really for tan, because tan keeps going. Okay, and then the period of these graphs. So the period, no, let's just leave tan out of this. So the period for sine and cos is equal to 2 pi, because that's how long it takes to complete one full cycle of your graph. So 2 pi radians. Same with cosine, it takes 2 pi to go through a full cycle before it starts to repeat itself again. And the equation of the axis that's where the middle of your graph is. So you can see the middle of our graph is right on the x-axis. So we call that y equals 0. So the middle of this is right at y equals 0. I would say the period of tan is just going to be pi. Okay. So we're going to figure out how to graph transformations of just sine and cos. Okay, so here's what you need to know. You need to be familiar with this equation again. F of x equals a sine or cos, I'm just going to put sine for now, k x minus d plus c. So these stand for the same things that they did last time. So A stands for our vertical stretch and compression. Vertical stretch or compression. So if A is bigger than 1, it's a stretch, the absolute value of A. And if it's in between -1 and 1, then it's a compression. If it's a negative A, then it's a reflection in the x-axis. And A also gives us our amplitude. So the amplitude of our graph is actually equal to the absolute value of A. K is kind of the opposite of A, so it gives us our horizontal stretch and compression, and in the opposite way, so it does a compression if the absolute value of K is greater than 1. So if K is like 2, 3, 4, 5, it's going to be a compression, and it's going to work kind of weird. It's going to be by a factor of 1 over K. And K is special because it tells us our period. So normally the period of our graph is 2 pi, but it's going to get divided by K depending on what K is. So if K was 2, that's a horizontal compression by a factor of half. So if you take K of 2 and sub it in, you'll end up with a period of pi, which makes sense because it just shrunk the period in half. Okay, D is going to be our horizontal translation. Okay, I'm not going to write that up. Your graph left and right. And C is going to be our vertical translation, which shifts our graph up and down, and also tells us the equation of our axis is going to be y is equal to c. So that's what all the stuff does, and our key features are given by C, K, and A. I told everyone in class that you could just apply the transformations one at a time while graphing them in the order of like A, K, D, and C. You could just apply transformations in that order to your graph, or you could plot your key features. Or another way is this weird way mapping notation. So it's where you take each key point, x, y, and you just apply transformations to each of them. So this mapping notation way, you just apply 1 over k times x plus d, since k and d are your horizontal transformations, and then a times y plus c. So you could take all of your key points and apply those transformations to them. So let's just look at one quick example, if I can scroll down. Okay, so say we had f of x equals, let's just do negative sine of 2x plus 1. So we've got an a value of -1, we've got a k value of 2, and we've got a c value of 1. So right away I know my amplitude of this graph is not going to change. It's going to be 1. I know the period of my graph is going to change because it has k values. So the period of my graph is going to be 2 pi divided by 2, which is just pi. And I know the equation of the axis is going to be y equals 1. So those are the key features of my graph. If I wanted to describe the transformations, I would say that tells me there's going to be a reflection in the x-axis. This tells me there's going to be a horizontal compression by a factor of a half, and this tells me my graph is going to shift up 1. So if I'm going to graph it, start with my original sine graph, pi over 2, pi, 3 pi over 2, 2 pi, negative pi over 2, negative pi. I'm going to start with my original sine graph, 1, 2, negative 1, negative 2, which starts at 0, goes through 1, pi, negative 1, 2 pi, down here, here. Okay, so there's our original graph. So I'm just going to switch colors. Okay, so if I'm going to graph my new points, so you can do so by applying your key features. So equation of axis is now at 1. So I know the middle of my graph is going to be here. I also know my graph has to get through an entire cycle by the time it reaches pi. And I know my amplitude is 1, so I'm going to max at 2, and I'm going to have a minimum at 0. If I want to use that mapping notation way, I would take my key points, so I would start with like 0, 0 for sine, and I would transform that by multiplying x values by 1 over k and adding d, multiplying my y values by a and adding c. So 0, 0 would become, since I have a k value of 2, 1/2 times 2. I would just apply like, so there's 1 over 2 times 0. There's no d, so that's it. And then negative 1 is a times 0 plus c, which would make my point 0, 1. So all that happens to this is it's actually just going to be here. So I'm going to assume like all my roots are just going to get shifted up 1 because a stretch and a reflection is not going to affect my roots. So we're all going to stay the same. Okay, and then if I want to look at another point, so say I wanted to look at pi over 2 and 1 and transform that. So I just have to do pi over 2 times 1/2, which would make it pi over 4. And then I have to do 1 times negative 1, which is negative 1, and then plus 1, which is 0. So now I've got a point at pi over 4 and 0. So I'm right here, point right there. So I'm just going to continue with this because I know what my graph's going to do. It's going to go back up here, and then at this point it's going to go to 2, and then back down because I know it has to complete a full cycle in pi. And this makes sense because it's a reflection of the x-axis, so it's like going the opposite way. Sine usually goes like up and then down. This one goes down, then up. And it's just going to continue in that form. So there you go. And I could keep it going over here. It's going to go there. And then there. So there's my transform. So it's got a period of pi is my period. An equation of axis at 1. So you can use this mapping notation to get you all the points that you need. You could just use them so you can see what the pattern of your graph is. And yeah, that's it.